Hello everyone, Mr. John here from Areteem Institute with our first Thursday tidbit for 2023. So happy new year to everyone there. Today we're going to do a few recent AMC 8 problems because the AMC 8 exam is coming next week. As a quick review, there's 25 questions, there's all multiple choice, no penalty for guessing. You have 40 minutes for this test. I'm going to link a blog post down below. If you have other questions about how the AMC works, I would check out our All You Need to Know blog post there for more information. But for today, we're going to just jump in and solve a few more difficult problems from the last two exams that there were. Lastly, good luck to everyone next week when you are taking the test. Now, first question is from last year's, the 2022 AMC 8. And we have a question about filling in numbers of the grid. So as we're reading the question, we want the sum of the numbers in each row and the sum of the numbers in each column to be the same. So this is our first piece of information that we can work with there. So if we do some checking of this, let's just do a quick little calculation, maybe double check some things there as well. We know that -2 plus 9 plus 5, this is 12. You wouldn't need to do this on the test, but just if we wanted to double check and be clear of things, we could also look at our final column. Notice these are the only two places where we have only numbers. There's no missing numbers there. 5 minus 1 plus 8 is 12 there too. So we can be confident then that our sum is equal to 12. We definitely have that piece of information that we can work with there. Now, there's different ways to approach this problem. It's going to turn out to be easier to look at columns in terms of our variables there. So if we look at this first column here, we then have that our -2 plus something plus x is supposed to be 12. So what has to be our missing number there? Well, -2 and 14 would make 12. And then we need an x and a -x to cancel. So we would have this -14 minus x if we wanted to fill in our missing number there. Now, you wouldn't need to write out variables. You could try to do some of the things I'm doing just in terms of in your head trying to figure stuff out. But I want to write them out here just so we have the stuff as well. In terms of our second column then, we have two missing things. So let's say we have a variable y here, and then we know that 9 plus the middle number plus y is 12. 9 plus 3 is 12, and we're going to need this missing 3 minus y in that scenario too. So now we've filled in our chart, at least in terms of the bottom row. If the bottom left is x, the next one is y, and then we can fill in the missing middle row from there here, using the fact that all of the columns sum up to 12 in this case. Now, what is the goal of our question? It should be pretty clear that, in fact, if you pick any x value, that'll then determine a y value, and you can find everything. But we have a few restrictions that we need to deal with. In terms of the restriction, the x in the lower left corner is larger than the other three missing values. So this is the piece of information that we have there. Now, I want to write out a couple of equations. I want to just say what this really says. This tells us that we know that x needs to be greater than y. We also know that x needs to be greater than 14 minus x. And we know that x needs to be greater than 3 minus y. Now, in terms of our question then, right, there's still probably infinitely many things, but we need to also find the smallest possible value for x. That's what our final question is asking about here. Now, if we look at these inequalities, one of them should jump out at us. One of them is only in terms of x. So we have this one here, and this tells us that x needs to be greater than 14 minus x. So this is 2x is greater than 14, and x needs to be greater than 7. So right off the bat there, first of all, we could get rid of answer choices. Remember that at the end of the day, we have answer choices that we could work with and try. So we would have x equals 8 or 9. If x needs to be greater than 7, a natural thing to try is x equals 8. And I want to stress that we don't know here that x can be 8. We still should go through and check this out there. We can actually do this really quick for our things. So suppose x is 8. So I'm going to squeeze in the 8 there at the bottom. Then 8 plus something plus 8 is 12. So we need to have a negative 4. Negative 2 plus 8 plus what? 6. And then 9 plus negative 4 plus 7 is equal to 12 there as well. So now we've filled in our rows, and double checking, it does work. In fact, the one we would need to be the most worried about is the 8 and the 7. So x is bigger than negative 4, x is bigger than 6, x is bigger than y minus 3, or 3 minus y, which is our 7 there. So final answer then is D. Backing up one moment, remember that actually we could just try out the answer choices. So if you were a little confused about this method or confused about how our strategy might work here and things like that, right? In fact, you could just think about this as, let's try out our answer choices and see which ones work. See which ones we can figure out from there and go through, and you could end up with that answer choice D there as well. Okay, so let's look at one final question then, one other question here. This one was from the 2020 AMC 8. Actually, the exams recently switched from being into the fall to the spring. So actually, this was the second most recent AMC 8. So skipped over 2021 during this shift there. So question is, we have rectangles R1 and R2, squares S1, S2, S3, and they combine to form this big rectangle that we have. So in the end, we get this 3,322 is the width of our rectangle, if you like. And then we can also talk about the length or the height of our rectangle here is 2022, right? So our width is 3,322 and our height is 2020 in this case. And our final question here is talking about the side length of S2 in whatever units we're using here, right? So it is, of course, generic units. We don't need to worry about any unit conversions or anything. That's what we have there as well. So the first thing we want to note here is that we have a lot of different ways of using the information given. So for example, if we're thinking about the length of the rectangle, the width of the rectangle here, we're thinking about this 3,322 units wide in this scenario. Right? There's a lot of ways you could go through about doing this calculation. For example, maybe you would say, okay, we take the length of R1 and then the side length of S3 there. That would give us that 3,322 wide. You could also do the side length of S1 and the length of R2. So you have all of these different ways of expressing it. In the end, we want to know about squares. What is the other advantage of dealing with squares? Squares have the same length and width. They have the same width and height, however you want to say it there. And so if our square S1, if we call that square as, right, we could label this here as S1 by S1, and maybe S2 just to not worry about overlapping names, just to make things clear, right? We could label these side lengths as S1, S2, S3. And in fact, if you look at this there, we can do this 3,322 width as the side length of the first square plus the side length of the second square plus the side length of the third square. So this is our key thing that we can talk about in terms of the width of this rectangle, right? What we're doing there then, piece by piece, we have S1 plus S2. Going vertical doesn't change anything, and then we go straight across. So S1 plus S2 plus S3 is giving us this 3,322 width of the rectangle. Now, what about the height? So if we look here and then say we have 2020 as the height in this case, we want to think about this again or see if we can talk about it in terms of the side lengths, right? The natural way to think about this might be, oh, well, it's the side length plus the, height of the rectangle 1 or something like that. But what if we start looking at this in terms of S1? So let's start by doing this height as we're going S1 straight down here. Now we had this trick of going over and stuff like that there. What if we want to go up? So let's say we go over, that doesn't change the height at all, right? And then we go up. Now that up would be like subtracting. So instead of actually having a plus here, I can turn this into S1 minus S2. And then if you go over and down, you actually get the plus S3. So we could go over and then down in this case there. I like thinking about this in terms of the paths we have there. But of course, you can think of this instead as, okay, we have the side length there. Can we find the height of R1? Well, the height of R1 is the difference of those two other sides, and we can think about that there. So these are our important pieces of information. We're expressing everything in terms of the side length. And now, when you look at these, you want to look at similarities and differences. What's the only difference between these two? One of them has a positive S2 and one of them has a negative S2. So if we think about this and think about, well, what is the difference between these two? If we look at 3,322 minus 2020, and if you think about subtracting those equations or looking at how they differ from each other, notice that they both have an S1 and an S3, but one of them has a plus S2, the other has a minus S2. So this difference should be double the side length 2. And this is our key piece of information here. This tells us then that 1302 is double that side length. So our side length is that divided by 2, which is 651. We actually don't have information about the other side lengths. We don't care. We just know about that square in the middle and how things work out from that point. You could do some other methods here. You could make some assumptions that S1 and S3 are the same. That would actually work out. And you would have a similar method there as well. But this is a nice trick of, okay, we're trying to find stuff about the square. Can we talk only about the squares and use that information to our advantage? So that will bring us to the end of this week's video. Thank you all for watching. Good luck to everyone on the AMC 8 next week. And stay tuned for some new problems or ideas next time. If you liked this video, please subscribe, give us a comment on what you might want to see next, and I'll see you all next time. Goodbye.